Question number 9, the cockroach problem. A cockroach is running at 1.32 meters per second toward your desk. If he is 3.87 meters away now and your desk is 1.19 meters tall, how fast do you push your calculator off the desk to smash him? So our diagram looks like this. We have a little roach to the right and he's running to the left, and you're sitting on your 1.19 meter desk, and you are going to take your calculator and you're going to give your calculator a shove. Of course, it should fall in a nice parabolic trajectory and squish the roach as the roach is running forward. So what we are looking for is what is the horizontal velocity of the calculator. Sorry, let's do that in yellow. So the VH is going to be GH over T. Well, we don't know what the DH is. All we know is that it's shorter than 3.87 meters. And the time is going to be the time it takes for the calculator to fall. So the first thing we want to do is find that time. So we're going to use the time down formula using the 1.19 meters. So these are the three formulas that we can use. Time down is 2dV over G. The DH is VHT. If we arrange that for VH, we get the DH over T that we looked at a second ago. The time down, of course, all we're going to do is take the square root of 2 times the distance it's going to fall, which is the 1.19 meters, over gravity, negative 9.81. And if we do that on the calculator, we get 0.493 seconds. So a little under half a second it's going to take to fall. Now, in that half a second, what's happening? Well, back here, of course, we know 0.493 is the time. But in that time period, the cockroach is running forward. So the second equation is saying, well, how far does he run? Well, he's running at 1.32 meters per second. So if we come back here, we say, okay, the cockroach ran 1.32 meters per second, but he only gets to run for 0.493 seconds before he gets squished. So if we take that times the 1.32, we end up finding that he runs 0.65 meters closer to you in the time it takes the calculator to fall. So if we come back over here, we find this is 0.65 meters closer. So basically we have our 3.87 meters is how far he was when the calculator started to fall, but he's gotten 0.65 meters closer. So we say, how much distance does the calculator have to cover? Well, the calculator has to cover the remaining distance. So that would be the 3.87 minus the 0.65. So if we subtract that out, clear that would be a 2, that would be a 2, that's a 3. So if we subtract that out, we find out the calculator has to cover the 3.22 meters in the 4.93 seconds. So if we take 3.22 divided by 0.493, we get 6.53 meters per second. The answer sheet says 6.54 meters per second. That last number is uncertain, no big deal if you say 3 or 4. So that is how you do the cockroach problem.